Okay. Okay. Hey friends, can I present? I don't know. Let's find out. Please. Okay. All right. Cool. All right. Welcome everybody. I'm Alex, and this is one of our intro to text to Python. So we'll kind of talk about the Python language and just gently introduce you to some of the semantics and how to actually program some really basic stuff in Python. Before I do that, let me just give my quick ACM spiel here. If you are not already a member, please become a member. Membership is free. The only thing or condition, I suppose, is that we ask you 7 meetings, which is about 20%. And if you do so, you get some benefits, like you get a T-shirt at the end of the semester, and you're eligible for swag giveaway, and you're also invited to spring networking and celebration events. So with sponsors and others and on. So we had one year, and it was quite nice. So that's who haven't scanned the QR code or like the link. If you're members already, if you are, good to go. Okay. Okay. All right. So just another quick reminder about our social medias. We have a Twitch, a YouTube, an Instagram, Twitter, a Facebook. We probably don't use that, and a LinkedIn. We use Discord the most, so if you want to keep up to date with our announcements, we recommend you just join our Discord. We'll probably post stuff often there, and instead of be up to, we'll also give updates there. We also upload our live streams onto YouTube. In fact, that's probably what some of you are watching this on. And we live stream to Twitch as well. I believe there are VODs, maybe. I don't know. Well, either way, YouTube will be where the archives are at. And if you are interested in becoming an organizer for Rowdy Hacks, which is our annual hackathon, please scan the QR code. And just to be clear, an organizer is basically someone who helps, well, organize the hackathon itself. And if you want to volunteer, I think you should. It's a pretty good thing. And they want people. People are cool. Okay. All right. Okay. And just a couple of upcoming events. So the College of Sciences is holding their Dean Student Board, basically just wanting to get feedback from students and what they think should and shouldn't change about the College of Science, and I guess their respective majors and the courses, etc. And we'll be giving a $10 gift card to 2 ACM members who attend. So if you want $10 for free for just sitting there. Wednesday, October 12th, 5 to 6 p.m. or not. All right. So a couple more of our upcoming events. So we have Pi Night, which is next Tuesday, I believe, or Wednesday. Sorry, I can't read. Or Tuesday. Next Tuesday, the 18th. That'll be to 4 to 8 p.m. To give you some context, Pi Night is essentially just a list of, or a 4-hour event by Booz Allen Hamilton, so a defense contractor or contractor. And it's basically filled with a bunch of Python challenges, usually involving data structures. If you're familiar with ICPC, it'll be in that vein. Probably not exact. I have no idea, but it'll be quite similar. And just a reminder again, we have our hackathon for marginalized genders and women. And that's coming on the first week of November, I think, the 7th and 8th, that weekend, the first weekend there. So if you're interested in that, also please feel free to register for either of these things. And I'll probably just give you guys a second maybe for those who are interested, and let them sign in. Okay. And if you would like to sign into today's meeting, please scan this QR code. Or if you want the link later, you can ask me. We'll show this again at the end of the meeting. So if you missed it, don't worry. We'll catch you up to speed. Also, if you have any questions, you are more than welcome to just stop me. I like questions. I like answering questions. Okay. Yes, Nico, person back. He had a fake question. Liar. I hope people on YouTube aren't offended by that. All right, so I guess we'll move on. Okay, so to get started, our setup, just so you can get familiar with Python. if you choose or would like to work on this on your own computer, you can go to that link over there and you can install Python. There should be a pretty obvious link for whatever your operating system is, Python, Linux, Windows, whatever. I would recommend, I think 3.7 or 3.8, maybe. Usually about that version is right. They'll tell you the latest version up there. You can also text editor or an IDE of your choice. Python or VS Code are fantastic options. Pycharm I know people like, and you can also get it for free as a student. Just make sure you use your my.utc.edu email as a student. Or if you prefer installing Python and you would just like to use a web-based IDE, that is also fine. You could just follow that link there. In fact, I may just try to show both options in case you are interested in doing so. And maybe just a second if anyone needs the link. Okay, everyone good?
I need to get that last.
Okay. Give you a second there. Don't want to move too fast for you. Also, let me know if chat has any questions. If chat does, I will answer them. All good? Okay. So I'll go ahead and move on. Most of this presentation, I kind of would like you guys to follow along. I would prefer you follow along. I think it's easier to learn things going along there rather than me lecture for 50 minutes and bore you. So, all right, I guess some motivation. Why exactly would we even bother with Python? You've probably seen people all around you be like, oh, Python is so cool. Python's my favorite language. I like writing in it, blah, blah, blah. So there's a fairly good reason why people are leaning more toward Python. Firstly, obviously, is versatility. Just to elaborate more on that point, Python has a ton of inbuilt libraries. So, for example, if you want a priority queue, if you're in data structures, which how many of you are in data structures at the moment? A couple of you. If you need a priority queue or a stack or some common structures, the Python library very likely has that for you. And if it's not included in your system, well, you can actually download it. So if you need help for a specific task, like say machine learning or computer vision, there are many libraries out there to help you do this. In fact, there's something called pip package manager, which allows you to install these external packages and use them, which is very handy. And if you have questions about that, you're welcome to ask them. And another point, ease of use. Python is fairly simple to understand and read. When you see pseudocode, Python kind of takes a very similar angle to pseudocode. Obviously, there's a couple of differences, but a lot of statements seem extremely obvious what they are, like printing a line of text is just print, for example, right? Like that's very obvious, and that's very helpful. And obviously, the last point is that it's fast enough. Yes, sometimes there are concerns about speed. Maybe you don't see because you like a systems programming language. What I mean by that more specifically is a language that allows you to easily interact with memory and hardware components. You may need that, but Python is usually sufficient enough for a task. It has very lenient limits, and it's relatively fast, and it does a pretty good job for most things. And in fact, I guess I would argue the versatility is the fact that it can allow it to do so many tasks. So I'll quit my blurb there, and I'll jump directly to actually programming things. And I want to kind of walk you guys step by step. So rather than me, again, lecture for 50 minutes and just provide you examples. So what I have pulled up here is an online IDE. You can use this. This is fine. Probably what I'll do is I will go ahead and use VS Code just to make my life a little simpler. And what I'll do is I will create a new file. And I'll just call it, I don't know, just a Python file. And so, I don't know, is that visible for you guys? Okay. So, so first things first, typically in Python, we have a hello world statement. So how many of you are familiar with this hello world statement? Probably most of you, right? I guess for the newbies, essentially a hello world program is a program that just prints hello world as text. And Python makes this extremely simple to do. all we do is we have this keyword print, which essentially allows you to print some sort of object or string onto the console, and we can put our quotation marks to represent the text we're actually printing, and we call these strings, and I'll kind of elaborate what more that is later, and we can just do hello world. So if we save the script, we'll just call it random, if I can spell. Is that right? I don't think that's right. That's fine. Okay. And so what we can do is so in VS Code, we can open up a terminal, and we can pull this terminal up here. And so what I can do is that I believe, let me just shift back. Is that saved in Basilisk? Okay, so what I can do is I can just do, if you have Python on your computer, you can just do Python, and then you can run your program. So in my case, random.py, or thank you, random.py. Or I guess I probably misnamed. Did I misname that file? Oh, ramdon. I guess I can't spell. Sorry, I'm sorry, guys. So if I run that file, I'm sorry, guys. I can see. Or.
You did random,
I'm sorry, guys. A couple difficulties here. So there you go. Just prints out after struggling for a bit. Just prints out hello world, which is what I kind of expect. So I guess just to dive a bit more deeper. So I know I previously discussed a string, but what exactly does a string mean? Many of you are likely familiar with what that means, but just again, to kind of elaborate, a string is essentially just a collection of alphabetical characters, or characters simply, and we can essentially combine individual alphabetical characters in order to make a list of alphabetical characters. What I say a string. So that is essentially what the hello world statement is. That is a string. It is a collection of characters, which in fact is interpreted as a character to the computer. But a string, essentially a collection of characters. But let's say, for instance, maybe we would like to store this hello world string somewhere, right? And maybe we want to know and then access it again. Well, we have a thing called variables, and we can actually use variables to store things in and refer to them. So kind of like, for example, if you had a box and you want to store stuff in a box, but then you want to take it out, that analogy is a lot like what a variable is. And in Python, variables are quite simple. So for example, if I wanted to say, let's say, and then we can use the equal sign to essentially assign string to a particular value or data type, which there are 5 main data types in Python, which are strings, floats, meaning decimal point numbers, integers, which are just numbers without decimal points. There's also Booleans, which represent a value of 0, 1, so true or false. And I believe I'm probably missing one somewhere, but I can elaborate more. So I say string equal to hello world. I can also print, which is this line we called previously, and I can say string. And oops, I guess I can't spell. Sorry, guys. String. And then if I save this file and I once again run, you'll see that it printed it twice. One where we actually just type out the whole thing, but one where we make a variable, store this hello world variable or contents into this variable, and then actually print out the variable itself. So you can see that variables are kind of an easy way to store stuff. So I guess more practical uses, let's say we had a number x, which is 5, so store the value 5 into this variable x, right? And then let's say that we would like to print x 1 point, right? Oops, can't spell. Print x. And then let's say we actually want to add 1 to x, which will also do something called expressions and operators. Operators are essentially just arithmetic, or so plus, minus, divide, multiply, etc. We can use operators to make expressions. And expressions are basically just longer lines which are like evaluate to something. So for example, when we say evaluate, what I mean is it kind of just mathematically adds 1 to x. And if we're interested in saying, let's print out x again and see the change, we can do that. And so you can see that in one instance at the bottom here, that may or may not be hard to see. In one instance at the bottom here is we have this 5 printed, but then after I added 1 and printed it again, now that x is 6, and we've printed it once again. And so just to, I guess, summarize a couple more of the types that I've mentioned earlier, right? So we can do, so let's say we can do, well, I just had 2. We can also do floats. So for example, 15926, let's say we have the value of pi, right? And we want to add 2 to pi, we can also do that. So just print x again. You can save that. And then let's try running our Python program again. So Python, or file name. And then we can see that, yeah, we can see that we added 2 to that decimal point number, or floating point number, as Python calls it. So I've explained kind of these integers, these strings, and kind of the whole thing. So what if, so I've kind of shown you that you can also refer to numbers, add 2 to them, and then refer to them again. So basically just changing and modifying the contents of said box, or box, going back to our box analogy. So we can also do a bunch of other stuff. So for example, we can multiply by 2. We can also divide by 2. So I'll just show you multiply just to make things easy. We can see that that looks like that's multiply by 2 roughly. We can say, I don't know, maybe we can want to cancel that out, and we also want to divide by 2 for whatever reason. Maybe you want to. I have no idea. You can also do Python, and then you can see that that value was multiplied by 2 and then divided by 2. And the reason it evaluates to this is because it basically evaluates these operators left to right. As most of you probably know, it multiplies it by 2, then later divides it by 2. So that's why you come back to the original statement. You can also have parentheses to prioritize these operators. So for example, if I wanted to multiply first, I could put these in parentheses, knowing the fact that this will always go first in parentheses, or this is first, and then this comes second. And just to rerun our program, you can see that that's, again, just the same result as last time. Okay, so I've shown you that you can store things inside of values. But what if, for example, you want to check for certain statements? So a lot of you know this as if statements or conditional statements. So what if we want to check for certain conditions in Python? Well, we can do that by using if statements, which, again, some of you likely know already, but I want to introduce that to you in a more Pythonic or Python way. So let's say we have some variable called bool, or boo, I don't know, bo. And let's say we set it to true, right? So a true value, so Booleans, remember, take a value of true or false, as I previously mentioned. So this is typically how if statements are evaluated, through the use of Booleans. And let's say I want to check if that Boolean variable I created was true. So I can just use if, and I can do parentheses, and I can check if bo is equal to true. And the way Python has these blocks is they separate them by spaces. Some viewers may be familiar with how C separates with braces instead of using spaces or tabs or indents. So what we can do here is if the Boolean is true, and notice how we use this double equal sign, that essentially evaluates equality. That if the one equal sign basically assigns, basically stores the value inside the variable rather than checks for equality, which is why we have these 2 equal signs. So if it is true, right? Let's say we want to print, I don't know, ACM, right? And then if this is indeed true, it'll print out ACM. So if I save this and I run my program again, which, yeah, you can see that it prints out ACM because this has evaluated to true and it's checked equality, and that has come out, and that is indeed correct, that is indeed true, it prints out ACM. But what if I change this to false, right? And if I run my program again, you'll notice that ACM does not appear. This is because false is not equivalent to true, therefore not printing ACM at all. But what if, for example, we wanted to say if something is true, or if something other than true wants to be executed or wants to run, right? What if we want that to happen? We can use a statement, which many of you are likely familiar with. And we can say that, oops, I guess I can't type. We could say that print, and then not happy, because we're sad, I guess. I don't know. So right now, we have this true, but let's change it back to false and see what happens. Or, oops, let's say we want to run this. You'll notice that this prints out not happy because this is so false does not obviously equivalent to true, meaning it jumps directly to the else statement because it's not true. So now it just prints out not happy. So it's not very happy, is it? Okay. So you can also, so you do have direct ways of evaluating Booleans, but you can also evaluate them in different ways. So let's say maybe you want to check a number greater than another number. And let's make x equal to just 1 again. Let's say y is 2, right? What we do is we can make this Boolean change, and we can probably check if, so let's say we make another variable called check, and then let's say we want to check if x is greater than or equal to y. So we can just do that by having kind of like an algebra statement. You can check if a certain variable is greater than or equal to another variable. And another thing I want to note is the way you express equals to, or if you're saying the greater than or equals to, you can express it as the greater than sign and then an equal to sign. You can also say less than or equal to, like this, which is basically just using the same sign. Well, it's a different sign, but you're including the equals. And then let's say in this statement we want to just do the check directly. So another shorthand way of checking if things are true is we can just have the word check, and assuming obviously that this is a Boolean, which does result in a Boolean because it's either a true or a false result, it'll basically check if check is true, it prints out ACM, and if it does not, then it prints out not happy. So let's try saving our code. Let's try running that again. You can see that it does print out ACM because this evaluates true. But what if we wanted to do greater than or equal to? And once again, save it, and then run our statement again. And we can see that it prints out not happy because that entire statement has been evaluated true. So you can store this result in a variable, but sometimes people may prefer to just directly do x is greater than or equal to y instead. And that's also perfectly valid. So we can run our program again, and obviously that prints out the result we expect because 1 is not greater than or equal to 2 because x is 1, y is 2. And I'm sure, yeah. And that's why that evaluates false. So now that I've shown you ways that you can indeed check for statements being true or not, what if, for example, I wanted to print this, I don't know, ACM statement 5 times here, right? Ordinarily, I could just do print ACM, and then I could just copy that 5 times, right? And that's also perfectly valid. I mean, it works, right? See, even our console's happy. But this is kind of tedious, don't you think? Especially if we're doing it 5 times. So what you can do is you can use something called loops, and loops are basically ways of repeating the same statement again. And you typically have, in languages anyway, 2 loops, a for loop and a while loop. So for and while loops, you'll see the keywords there. Essentially, for loop typically when you know you're going to print something a certain amount of times. So, for example, if I would like to print this statement 4 times, I can do for I in range 4. Whoops, I guess I misspelled. Range 4. And what this basically does is it basically says, okay, so for I 0 through 3, because this range thing is an expression in Python where you can essentially go from 0 to 3, and you can, range basically is exclusive, meaning it starts at 0 but does not include the number you put here. The only exception to this is if you give it more parameters. And so let's say I don't know, so let's say I want to just print the value of I, which we can, because this is a variable here, we can print I, and we can see what the result is. So if we go back here, we can see that it goes from 0, 1, 2, and 3. We can obviously change this as well. So let's say we want to start at 1, and we include 4. We can also do that, and we run our program. you'll notice that it actually does not include 4. Oh, right. Yeah, my bad. Yeah, it does not include 4, but it does start at 1. So this is inclusive and this is exclusive. So that's basically how you print something, or how you do a certain action a certain amount of times. So what if you would like to loop while a condition is true? Well, while loop, as many of you may or may not know, also is for that purpose. So let's say that x is 5. So make b assign the variable x to 5, right? And then let's say that, so we can have our while loop. So while x is greater than 5, or x is greater than 0, we commit some body. Yes, question in the back?
Can you make them all print out the same line?
Wait, sorry.
Make them print out in the same line using the loop.
So in Python, you can change the end to be so you can change the end rather to be a new line, to be on the same line. But I guess just for simplicity, we can omit that for now. You can't do that though. You can't do that though. I forgot. Sadly. So so let's say that you want to evaluate this so you want to iterate this a certain amount of times while x is greater than 0. You can basically print out, let's say we want x at every point, and then let's say we want to make x, or subtract 1 from x every single time. So we can do exactly that. And if we save this, and we go ahead and run it, which kind of hard to see my cursor. There we go. Kind of. Oops. My cursor's all over the place. Okay. So if you run our program again, you can see that you start at 5. It's a little hard to see here. You can start at 5, then you go to 4, 3, 2, and 1, and because afterwards it subtracts 1, and that's not greater than 0, it exits that loop. So it basically checks while x is indeed greater than 0, continue executing the statements of this loop. So, yes, you had a question?
So the response we want is process exited.
Typically, when you're running a Python program,
Yeah, no, because I typed in all that and I got process exited.
that may be a problem if you have either if it doesn't find Python on your laptop, or you may have like put in the entire file like in the command line. I can help you with that. I can help you with that later if you like. Typically, that's not the result you want. You only want what your program has printed so far. Okay, so I can answer your question later. Yeah. So let's say I've kind of taught you how to loop through things, how to check if something is true or not. But let's say that, for example, maybe we would like to store multiple things inside of one variable, right? Now you want to store a collection of items. Python offers kind of a convenient way to do this called a list. And a list basically stores a collection of items. And the way we make a list is basically through using brackets. So let's say we have a variable called our_list, and we give it these brackets, which basically notate that we're making a list. And then let's say that we want to have the numbers 1, 2, 3, and 4 in our list. So we have entry 1, and they're all separated by commas. So 1, 2, 3, and 4. So meaning these are all entries. So the way you separate these entries is through a comma, meaning this is one entry in the list, this is one entry in the list, and so on and so forth. Question in the back?
What if you replace like the second value of the string?
I'm sorry, could you repeat your question?
So like, what if you replace like instead of 2 you put a string?
That is also valid. So so many people are probably familiar with arrays in another language like C and Java. Python lists can actually contain items of multiple types. So for example, this is valid, and let me quickly just print, so we can actually print out our entire list. And let me just run this program again. Oops. And so if we do, we can see that our entire list is printed out here like this. But like you mentioned, or like I mentioned, you can indeed put strings here. So for example, if I put, I don't know, banana. I can't type. Yeah, thank you. if we put banana there, right, and we run our program again, Python will actually take that in. So it does accept lists of heterogeneous types, meaning they don't have to be the exact same type. They can all be different types. That like this is perfectly fine. And it kind of depends on what you are looking to do. You use something like this to begin with. But yes, to answer the question, you can indeed do that. So I mentioned that we can store multiple items inside of a list. But what if and we've only printed out the entire list, but what if I only want to print out a certain object of the list? So only one object of the list, not all of them. Well, we can actually, if we call our list variable again, and we use the bracket like this, and let's say we would like to print out this first value here, you would think instinctively, because you usually start with 1, that's a 1, but actually it turns out that's wrong, because if I do 1 here and I rerun my program, it actually prints out banana, which is the second item in the list. So the way this actually works is that it's indexed through by 0, meaning 0 is actually the first element, and not 4 is the last element, but 3 is the last element of the list. So if I print out our list 0, and let me make sure I save this, and I run our program again, you'll notice that now it actually prints out 1, which is what we want. But if I say 3, because that's the last item here, it'll print out 4. Make sure I save. Oops, I guess save. There we go. It'll actually print out 4 because that's the last item on our list. So this is a very kind of handy convention. So maybe we want to extract items. Maybe we're given a list of values and we want to extract items. But maybe what if we only want to extract multiple like items, right? Like maybe what we want to do is like we want to extract values, the first 2 values of the array, right? So a neat thing Python has is something called list splicing. And what that basically does is it allows you to splice a list or split a list into what elements you do and don't want. So let's say I only want the variables 1 or the elements of the list 1 and banana. If I do, so I can do colon and I can do, I believe, 2. And this is actually, and so the reason we do 2, and let me make sure I have this right there. Right. So the reason we do 2 is because this is basically excluding the second element. So third, technically second element. So we're basically saying 1, so the 0th element, the first element, and excluding the second element. And if let's say I maybe want to start at just banana, I can actually just index that as is. So if I put 1 there and save, notice that only banana is printed. So the way this list splicing works is that this first entry is inclusive, while this last part with the colon is exclusive, meaning it contains up to but not including a particular value. So if I, for example, 4, this is actually valid because it prints out 0, so it prints out 1, 2, and 3. So that's why this is valid, because it's exclusive and it does not include the 4th element. If I did 5, however, that would likely throw me an error, and an error is basically a handy way of telling me it's wrong, or rather, because this is out of bounds, right? It doesn't really consider it. So that's why it's not really considered. So this is perfectly fine. This is valid, and this is a way of basically saying like, oh, I want parts of a list. But what if you want maybe say the even entries of the list? So you only want banana in this 4th list. So we can actually make sure let's start at 0. We can actually use the colon once again, and we can actually skip by 2 each time, I believe. I think my memory serves me correctly. So look at that. So we can actually print out 0, then 1, and then not obviously not including 4. So we can actually print every other entry in the list doing this method, where 2 is basically how many kind of elements we're skipping by, or how many elements we skip. So like we skip 1 and we do 2, or we do the second element in the list. So this is kind of a handy way, as I've kind of explaining. This is a handy way to utilize lists to store information and collect certain items in the list. And so maybe let's say that what if we want multiple lists or lists of lists? Like maybe you're evaluating a matrix. You have a 3 by 3 matrix. You have 3 rows, 3 columns, and maybe they carry 1, 2, 3 left to right, and then 4, 5, 6, 7, 8, 9. And so the first 3 values are first row, and so on and so forth. So I can actually, because of the question someone asked earlier, where can you store other objects in lists, multiple types of objects in lists, that is true. And it's actually nice because what we can do is we can say our list new. So let's say, so we can have a list. We can also have a list of lists. So we can include a list as one of our elements. And let's say we want to make a 3 by 3 matrix. So 1, 2, 3, right? So that's our first list. The second list can be 4, 5, 6. And our last list can be 9. So if we actually come back and let's say we can do print our list new, we can actually run this and we'll see that our entire list is printed. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the problem is, well, what if we want to only take in just this 2 value here? So we can actually do that a pretty similar way to how we referenced individual values. So if you remember, the way we reference individual values was just with this bracket. So in this case, this 0 takes in the first element or the 0th element, meaning it only takes this first list. So if I save and I rerun this program again, you'll notice that only that first list is printed. But if I would but because this is also a list object, we can actually index that once more to get the 2 value. So I'm indexing the 1th value or the 2nd value in the array, and if I see my list, we can actually see that I get that 2 value there. So we can actually have n rows and n columns of matrices, and we can actually evaluate them using a similar way to how we did just ordinary lists. And maybe let's say, for example, that I would like to iterate through all the lists and print them out. So if we remember our loops, right, we can do for, and we can actually just do I in, well, let's say for I in our list new, and basically what this is shorthand syntax for saying for each element in the list, meaning, so for each list in this list of lists, let's say we want to actually print out each element. So we can use I, because I is basically the local variable, or the variable we are using to loop through this list. So if we save that, notice how it actually prints these lists individually. It prints the first list, then the second list, then the third list. But let's say maybe that, I don't know, I want to take the first element of each list. Well, because each I is a list element, we can actually index them, and we can say that we want to take the 0th element of each list. And if we say that, we can actually see that it takes 1, 4, and 7, which are indeed the first values of every list. Yes, question? Like, that's so they're asking you to do I of I. So why don't we go ahead and try that and see what actually happens here? Great suggestion. And let's try running it. Well, see, so this is a problem because it expects a list index, and it's not expecting a list to be an index itself, which is why that doesn't work. So that's why this doesn't actually work, because you're basically using a list as an index, which you can't really do. You typically only use a integer number, meaning a number without decimals, as a way to index this list. So if I just delete this, and let's say I just print out each list, and we can just go back to normal, how we had it. Okay, so I taught you how to actually index each list, but what if, so many of you may or may not be familiar with functions, right? Functions are basically ways of reusing code. Like think, for example, back to your algebra days for the new people, f of x, right? So f of x might have some variable x that you refer by, and maybe it's f of x equals x plus 1, meaning f of x takes in some arbitrary value x, and it increments that by 1. And so we can do a similar thing on Python where we can define functions. We can define these reusable statements, so kind of like these algebra functions. And the way we do that is we typically give it a def keyword, meaning this defines a function, and we can give it a name of a function. So let's say our name of the function is f, and then we can take in parameters. Remember, kind of like how in algebra we take in some variable x. This is what we call a parameter, right? So we can take in function f with some variable or parameter x, and we can say, in order to actually signal that what the function is giving a value, a resulting value as, we can do return, which basically is like returning, or it is the value, it is what the function will evaluate to. So if we do, let's say we want to increment 1 to x, we can do return x plus 1. And what this does is it takes this x and it increments by 1 when we call a function, and it returns that value. So if we do, for example, let's say that, and we call functions by just doing the name, calling the name, and in parentheses we put whatever number, in this case number, because we're expecting a number, we would like. So if we do f of 5, that is basically saying, that basically replaces x with 5. So it returns 5 plus 1. And if we print out, and print itself is actually a function, it does take in parameters, like this is technically a parameter it takes in. And let's say we print f of 5, you'll see that it prints out 6 because it basically just takes that value in and increments it. But what's also interesting about functions is we can take in multiple parameters or multiple values. So let's say we want to take another value, y, and let's say we want to increment by y times 2. And if we say that f takes, let's say x is 5 and y is 2, we can save that, and we can print it again, and notice how it does indeed return 18, because that's 2 times 2 plus 6, or, yeah, 10, sorry, I'm a little blind. 5 plus 1 plus 4, which is indeed 10. So I've taught you how to do functions, and these are all very useful constructs. So for example, maybe if I combine everything, or combine most things, and let's say I would like to print out a string multiple times, we can do like print many. And let's say we want to take in the string as one parameter, and let's say the number of times as our x, or as y being the number of times we print the string. And then again, we can use a for loop because we know we're iterating a certain amount of times. And we can say for I in range 5, so this meaning 0 through 4 prints it out. It does the action 5 times, or this is just, it's 0 through 4, but if we're doing y, right, y expecting some integer variable, so y times, right, and we can print out our string. And in Python, you don't actually have to have functions return anything. So although you can have them return something, some people choose not to return something, and there may be a good reason for it. It purely depends. So if I do print many, and again we can call this function like so, print many, and let's say we want to print out, I don't know, ACM, and let's say we would like to do that 5 times. If we save and we run it again, or thank you. That's a little hard to see here. So if I do print many, you'll notice that it prints this thing 5 times exactly. So it's what we expect, because it takes in the value 5 for y, being the number of times we iterate, and it takes in that ACM as a string, and it basically replaces it when we call the function. I think this covers most of the basics for Python. Let me quickly switch back to my presentation and give you 5 seconds. Okay, so I do want to go over a more practical example of a tic-tac-toe game, but I don't think we'll have time for that. If anyone wants the source code, I'll probably push that later to GitHub just to give you guys an example to work with. And you can obviously improve it. There's a ton of libraries. Now, I've recommended a couple here. So if you want website data, Beautiful Soup is a good library. If you want to do game development, Pygame is also good. For machine learning, TensorFlow and Scikit-learn are excellent libraries. And then I've listed some other ones there for web development and GUI development. And I also recommend you use the Python reference documentation, as well as some other documentation. Google is your best friend. Stack Overflow is your best friend. They'll answer 90% of your questions, unless it's something weird and esoteric. But let's forget about that. So those should answer most of your questions. So if you'd like to sign in, please sign in. This has concluded the presentation. And if anyone has questions, please come to me.